R284C3M1B7C8E13C9C6D3P38D10. Line 22f1fa19C3M1B7C8E13C9C6D3P38D10. Ammeter Shunts voltages 5G Wow Seti. Here's our alien radio signal. Ammeter shunts from Constantan copper-nickel alloys and voltage. Keyword research for a UFO spaceship from the wild data. Next keyword will be cupronickel nanowires. February 24, 2013. Today's the 27th. Constantan from copper-nickel alloys is a keyword research to Manganin to ammeter shunts from a previous video. Line 22f1fa19C3M1B7C8E13C9C6D3P38D9. Constantan Manganin shunts 5G Wow Seti. So the keyword is ammeter shunts. Quotes and diagrams are from Wiki. Using current measuring. This is a 50A shunt resistor. An ammeter shunt allows the measurement of current values too large to be directly measured by a particular ammeter. In this case, the shunt, a Manganin resistor of accurately known resistance, is placed in series with the load so that all of the current to be measured will flow through it. The voltage drop across the shunt is proportional to the current flowing through it, and since its resistance is known, a millivoltmeter connected across the shunt can be scaled to directly display the current value. In order not to disrupt the circuit, the resistance of the shunt is normally very small. Shunts are rated by maximum current and voltage drop. At that current, for example, a 500A 75 MV shunt would have a resistance of 0.15 milliohms, a maximum allowable current of 500 amps, and at the current, the voltage drop would be 75 millivolts. By convention, most shunts are designed to drop 50 MV, 75 MV, or 100 MV when operating at their full rated current, and most ammeters consist of a shunt and a voltmeter with the full-scale deflection of 50, 75, or 100 MV. All shunts have a derating factor for continuous use, 66% being the most common. Continuous use is a runtime of 2+ minutes, and at which point the derating factor must be applied. There are thermal limits where a shunt will no longer operate correctly. At 80 degrees, thermal drift begins to occur. At 120 degrees Celsius, thermal drift is a significant problem where error, depending on the design of the shunt, can be several percent, and at 140 degrees Celsius, the Manganin alloy becomes permanently damaged due to annealing and resulting in the resistance value drifting up or down. If the current being measured is also at a high voltage potential, this voltage will be present in the connecting leads to and in the reading instrument itself. Sometimes the shunt is inserted in the return leg grounded side to avoid this problem. Some alternatives to shunts can provide isolation from the high voltage by not directly connecting the meter to the high voltage circuit. Examples of devices that can provide this isolation are Hall effect current sensors and current transformers, see clamp meters. Current shunts are considered more accurate and cheaper than Hall effect devices. Common accuracy of such devices are, there's the calculations there, in North America and 0.5% in the rest of the world. The Thomas type double Manganin walled shunt and MI type improved Thomas type design were used until the 1990s by NIST and other government labs as the legal reference of an ohm until the advent of the quantum Hall effect. Thomas type shunts are still used by government and private labs to take very accurate current measurements, as using quantum Hall effect is a time-consuming process. The accuracy of these types of shunts is measured in the ppm and sub-ppm scale of drift per year of set resistance. Current measurement techniques. So here's a diagram here. Low side current shunt. So the low side insertion can eliminate common mode voltage, but not without drawbacks. Here's another one that says high side insertion resolves low side drawbacks but guarantees common mode voltage. So there's a picture there and there. Can't read it, too tiny. Okay, so where the circuit is grounded, earthed on one side, a current measuring shunt can be inserted either in the undergrounded conductor or in the grounded conductor. A shunt in the undergrounded conductor must be insulated for the full circuit voltage to ground. The measuring instrument must be inherently isolated from ground or must include a resistive voltage divider or an isolation amplifier between the relatively high common mode voltage and lower voltages inside the instrument. A shunt in the grounded conductor may not detect leakage current that bypasses the shunt, but it will not experience high common mode voltage to ground. The load is removed from a direct path to ground, which may create problems for control circuitry, result in unwanted emissions, or both. My thoughts. The quantum Hall effect came up earlier in the well data from lines 1 to 22. Not sure if this will be part of the formula. We'll keep researching to see. Even though I did the research on the quantum Hall effect, I didn't really understand what it was for. Now I'm kind of getting an idea that's got something to do with some wiring. So the keyword cupronickel nanowires will be in the next video. Thanks for watching.